in mathematics. Hello, welcome. Today we are going to be looking at longitudes and latitudes. And this is a topic under Measuration in mathematics. Now, when you have an object and you want to know the distance from one point of the object to the other, or you want to know the area of the object, or you want to know the volume that the object occupies, you study this under Measuration. So let's say you have an object, say a rectangle, and you want to know the distance between point A and point B. Or you want to know the area occupied by this object. You want to know the total area occupied by this object. Or if this object is a solid object, if it is a solid object and you want to know the volume of this object, you can study either the area of this object, the volume, or the perimeter. You can do all these studies under Measuration. But now when you're looking at the Earth surface, you're not talking about any other object, you're not talking about a square, you're not talking about a rectangle, you're not talking about a cone. Now you're considering the Earth surface. This is the shape of the Earth. It's a sphere. The Earth is a spherical, the shape is spherical. So when you're talking about calculations on the Earth surface, noting the distances between points on the Earth surface, you use longitude and latitude. I hope you get the relationship. And that is why studying longitude and latitude is also classified under Measuration. In most mathematics textbooks, you see it under Measuration 2, because it is also studying about points on the Earth, noting the distance and understanding how to do calculations on the surface of the Earth. And that is what we're going to be doing in this course, Measuration for longitudes and latitudes. Now, looking at the shape of the Earth is a spherical object. It is very important that we identify some important points on the Earth. So, now when you look at the Earth, that very cycle at the middle of the Earth, the horizontal cycle, is known as the equator, whereas the vertical cycle is known as the Greenwich meridian. So these very 2 points are very, very important, and they are known as great circles, because if you cut the Earth through this very circle, you're going to find 2 equal parts. So any point, any circle round the Earth surface, any circle round the Earth surface through which when you cut the Earth you can get 2 equal parts, we call them the great circle. We call them the what? Great circle. And the 2 major important great circles are the equator and the Greenwich meridian. And they are going to be used as reference points in the calculations that we're going to be doing under longitudes and latitudes. So very importantly, take note of these 2 points: the equator, which is the circle through the middle, the horizontal circle through the middle of the Earth's surface, and also the Greenwich meridian, which is the circle through the middle of the Earth's surface also, but this time around vertical circle. So take note of these 2, the equator and the Greenwich meridian. Though these are not the only 2 great circles, most of the, or all the meridians, apart from the Greenwich meridian, most all of them are all great circles. So, what is the objective of this very course that we're going to be doing? What are we expected to know after this course, Longitude and Latitude under Measuration 2? Number one, after this course, you should be able to distinguish between a great circle and a small circle, which is what I've just explained. A great circle is that circle that when you cut through, you have equal halves of the sphere of the Earth. Like when you cut the Earth through this equator, you're going to have two equal parts. Or when you cut it through the Greenwich meridian. There are plenty other great circles as longitudes, but the Greenwich meridian and the equator are the two major great circles. Now, number two, you're going to be able to identify the longitudes and the latitudes. Now, what are the longitudes and latitudes? Now, the longitudes are those circles. If you want to run circles across the Earth's surface, you can run as many as you want. You can have this. You can have this. So all these circles that are vertical, all the vertical circles like this, they are all called longitudes. They are called longitudes. Whereas this other circle that you have, like the equator, and any other circle you have like this, cutting the Earth into two places, they are known as latitudes. So the horizontal circles are the latitudes, whereas the vertical circles are the longitudes. So take note. And like I said, the most important latitude is the equator, whereas the most important longitude is the Greenwich meridian. So that's why we noted it here. The most important longitude is Greenwich meridian. The most important latitude is the equator. So take note of this. You see, I just outlined the objectives and already we are solving them. So at least we get them to where we start doing calculations, which we'll do in the next class. Now let's look at the third objective. Determine and sketch the position of a point. Now, if you have a point on the Earth's surface, if you want to calculate distances on the Earth's surface, like distance from one point on Earth to the other, distance from Nigeria to Canada, knowledge of longitude and latitude can actually help you. So let's say you pick a point here, and this point is in Nigeria, maybe in Abuja or anywhere. You can, if you locate this point, you can find the longitude and you can also find the latitude of this point. So when you give us the longitude and latitude, you are giving us the position of this point. So anybody that you tell that this is the position of this very point, he can easily locate it. Now we should also be able to calculate the distance between 2 points on a great circle. And I told us that great circles are those circles that if you cut the Earth through them, you get a perfect equal sides. So let's say you cut the Earth through this circle, you are going to have equal sides. Once you cut the Earth through the equator, you get two equal parts because the equator is a great circle. If you also cut the Earth through the Greenwich meridian, you also get two equal parts if you cut the Earth through this. So now, if you want to calculate the distance between 2 points on a great circle, this is a great circle, the equator. So let's say you want to calculate the distance between point B and point A. So you should be able to find a way of calculating this distance between point B and point A and point B. So it's part of the things we are going to be learning under longitudes and latitude. You should also be able to calculate the distance between 2 points on the parallel of a latitude. So if you also have another latitude here, which is a small circle because it's not dividing the earth into two equal parts. You can also calculate the distance between C and D. So we can always do this calculation. Now we can also calculate the speed of a point on the Earth's surface due to rotation. So if you want to calculate the speed of a point on the Earth's surface due to rotation, we should also be able to do this calculation under longitude and latitude. So those are the objectives of this very lecture. Should be able to distinguish between great circles and small circles. And this objective, we've been able to solve them up to this point. So in subsequent classes, we'll be doing the remaining calculations. So let me go through them again. Number one, distinguish between great circles and small circles. And I said that a great circle is any circle through which when you cut the edge, you can have equal part. Let's say you cut the edge through the equator, you'll be having something like this. If you cut through the equator, you have two equal parts. But let's say you come to this other latitude and you cut the earth through here. What are you going to be having? You'll be having something like this. So you can see that this one is bigger, whereas this is smaller. So when you cut the earth through this very latitude, you're not going to have two equal parts. So this very circle, or this very latitude, is known as a small circle, because you cannot get two equal parts of the earth when you cut through them. But the one that through which when you cut, you can get two equal parts, like the equator, is a great circle. So that's why great circles, the latitude that is a great circle is the equator, whereas most of the longitudes are great circles. Because if you cut the earth through these points, you're going to get two equal halves. So the Greenwich meridian is a great circle. If you also cut the earth through these other points, you also get two equal parts. If you cut through these points, two equal parts, through these points, two equal parts. So you have plenty great circles as the meridians. Note, another word for the longitudes are meridians. So you have plenty of great circles as longitudes. But the latitude, the great circle there is the equator, because it is through the equator that you can have two equal parts. So whenever you hear the word meridian, you're also talking about longitudes. Now, identify the longitudes and the latitudes. I told us that the vertical circles across the Earth's surface are known as the longitudes, whereas the horizontal ones are the latitudes. And the most important horizontal or the most important latitude is the equator, because it is a reference point for measuring other distances. Whereas the most important longitude is the Greenwich meridian, because it is also the reference point for measuring other points and meridians on the Earth's surface. So that is where we're going to be stopping. And I believe that you've known what great circles and small circles are. And you can as well tell me what longitudes and latitudes are. So in subsequent classes, we'll be able to determine and sketch a point on the Earth's surface, calculate the distances between 2 points. Or please, if you like this video, hit the subscribe button by this side of the screen. If you have any questions and concerns, drop them in the comment section below. If you want to contact us, you can always use the reference points on the description section of this video. Thank you, and God bless you. Hello, welcome. Today we're going to be calculating distances along great circles. This is the first calculation part in the longitude and latitude lesson that we started. So let's look at this problem and see the way we can solve it. So if you have a problem like this in JAMB or WAEC, the positions of Accra in Ghana and Lagos in Nigeria to the nearest degree are 0 degree north, latitude, and 9 degree east, and 0 degree north and 32 degree east. That is the latitude and the longitude, respectively. Calculate their distance apart along the equator. Very, very important. Whenever you're calculating for distances along great circle, it has to be either along the equator or along the meridians. So note, latitude 0 degree north is the equator. So whenever you get latitude 0, it's always the equator. And that is what was given here, equator, and is also given here. So whenever you're told to calculate distance between 2 points on the Earth's surface, you check the one that is consistent. You see that the latitudes are the same. That means that this is done, the 2 points are on the same latitude. You can see the 2 points, L and K, the distance between here and here. That is what you are told to calculate. 2 of them are on the same latitude, which is 0 degrees north. But their longitudes, if you take a circle here, take another one here, you see that their longitudes are different. So you're told to calculate this. Now, if you're given this problem, don't go confusing yourself. Just check the ones that are different. You see the longitude here is different from the one here. So you just consider these two things. If it is east-east, add up the two longitudes. But if this one is east and this one is west, no, if it is east-east, subtract. Or if it is west-west, subtract. But if this one is east and this one is west, add them up. So in this case, you have the latitude for this one east, this one east. So simply subtract because they are the same thing. Understand? So we have 32 minus 9, 23. So anything you get, just do that thing all over 360 times 2 pi r. The answer is the distance between the two. Now, had it been we have 39 west, this one is west and this one is east, you have to add the two of them. So anything you get from adding the two of them, put that thing all over 360 times 2 pi r. It becomes the answer. So you see that this is very simple. You don't need to suffer yourself much. Just look at the positions of the two places that you are given, Accra and Lagos. The one that is constant is the gray circle that you're calculating across. Then check the one that is different. If the position, if it is east-east, subtract. If it is west-west, subtract. But if you have east-west, add. If you have west-east, also add. And this is for across the equator. Let's say you have another calculation and you have points. You have points A and points B, and you are told to calculate the distance between these 2 points. How do you do it? So if you have here 30 north and here 45 south, how do you do it? The same thing you do here, but since you have north and south, they are not the same, so you have to do what? Add. So you have to have 30 plus 45. Anything you get all over 360 times 2 pi r. The same thing. So just check whether you are calculating across the equator or across the meridians. It's just the same simple answer. Anything you get, the difference in the angles all over 360 times 2 pi r. Very simple. And note that your r is always 6,400. That is the radius of the Earth. 6,400 kilometers. That is your big R. Pi is always 22/7. So that is how you go about the calculation. Anything you get as the difference in angle all over 360 times 2 pi r. That is the formula for calculating the distance along great circles, whether it is across the equator or whether it is along the equator or along the meridians, whether it is along the equator or along the meridian. So whenever you're given a question like this, just look at the positions. If this is the same, east, subtract. If it is west, subtract. If it is east and west, add. If it is west and east, add. The same thing if you're considering the, had it been you come here, you came here and you saw 9 here and also 9 here. Now you now have here 31 and here you have 12. What are you supposed to do? You're supposed to forget about this because this is the same as this. They are constant. That means you're calculating along the meridian. So this is what you're considering. And 2 of them are not knots. So what do? You subtract. It will be 31 minus 12 all over 360 times 2 pi r. But had it been you have 12 south, like you have here, 12 south and 31 north, you have 31 plus 12 all over 360 times 2 pi r. So that is how you go about solving for distances along great circles. So once you see your question, look at it very well, analyze it before you solve that. Now, why did we have to subtract in order to get 23? Now, if you look at this question now, this is the initial diagram that is given. Now, it is being calculated along the equator. So this equator is a circle on its own. And that is the circle that I brought out here. Now, from the middle, you have point K. From the middle, point K. From the middle, point L. From the middle, point L. From the middle, point G. From the middle, point G. So this circle is actually the circle of the equator, actually. So I brought it out to be clear. Now you're given that the first one, GK, is 32, which is this one. Oh, I've already cleaned this up. I had 0 here and 0 here. So just note I have 32 and 9. So from here to here is 32 degrees. Whereas from here to here is just 9. So what will be this remaining place? You'll see that it's going to be 32 minus 9. And that's why we have 32 minus 9 here to have 23. So the 23 all over 360 times 2 pi r, solving down, gives me this kilometer. So this is the distance. If I approximate to 2 significant figures, I get this. So very, very important. What you're going to go home with in today's lecture is that once you're given a problem on distances along great circle, just get to know the difference in the angle. Check the angle where you have the difference. If they are the same direction, you subtract. If they are different directions, you add. So any difference in the angle all over 360 times 2 pi r gives you where r here is equal to 6,400. So that is how we go about this. Please, if you like this video, hit the subscribe button by the side of the screen. If you have any questions and concerns, drop them in the comment section. If you want to contact us, check out the description part of this video. Thank you. God bless you. Hello, welcome. Today we're going to be looking at distances along the parallels of latitude under longitudes and latitude. Now, how do we solve problems relating to distances along the parallels of latitude? Now, let's take an example so that we can study this. Now, find the distance measured along the parallel of latitude between 2 points whose latitudes are both 56 degrees north with longitudes 23 degree east and 17 degree west respectively. Now, I told us that whenever we have problems of calculating distances in longitudes and latitude, now given that both points, this point and this point, have the same latitude. Now we check the longitudes. We check whether the position or the direction are the same. If the directions are the same, like this is west, this is east, so they are not the same, that means you have to add. But if it is west-west, you have to subtract. If it is east-east, you have to subtract. But because this is east and this is west, you have to do what? Add. And that's why we added the two angles to get this. Now, when we are calculating along great circles, that is along the equator and the meridians, we said that once you get the difference in the angles, whether you are doing addition for the one that has different directions, or you're doing subtraction for the ones that have the same direction. Now, since you're having the one with different directions, you have to add. So once you get that difference in angle, whether you get it by addition or subtraction, just do what the angle is, all over 360 times 2 pi r for great circles. But if you're talking about latitude, parallels of latitudes, instead of having 2 pi r, where r is the big R of 6,400, you're going to be having this small r. And this small r is the same thing as saying 2 pi the big R cos the angle of the latitude. So that is the major thing that you need to understand about this calculation. It's still the same thing. Get the difference in angle all over 360 times 2 pi r. But instead of having the big R as in the calculation for great circles, you are now having small r. And the value of this small r is simply 2 pi the big R cos the angle of the latitude. So once you fix that, you're going to get this. So that is the main point, and that is the main thing that you're going to be looking out for, because in the exam condition, you may not have time to be making all these diagrams. These diagrams actually makes this solution very simple. But if you're in the exam condition, you might not be drawing to explain all this. This is what you go through. Check out the angles, provided they are having constant latitude. Check out the longitudes. If they are having the same direction, if it is east-east or west-west, subtract. But if it is east and west or west and east, add them up. Then the angle that you get all over 360 times 2 pi r, if it is for great circle. But if it is for parallels of latitude, 2 pi small r, where the small r is equal to big R cos 56, cos the angle of the latitude. And that's how you go about it. But if you want to look at this critically, this is where it is represented. These are the 2 points. We have this point and we have this other point. This is the R. So if you consider this angle CAO, you're going to find out that this small r is equal to this big R cos 56, which is this angle. And that is how we come about this. Now CAB is simply the addition of these two angles, giving you 40. So that arc CB will be equal to 40, which is total of this all over 360 times 2 pi r. That is the formula for an arc. But this small r is actually equal to r cos 56. So in place of small r, you put r cos 56. So the same formula of the arc, so that you can solve that. You know that 2 pi r is the same thing as saying 2 times 22 over 7 times 6,400 to give us this 40,000. So when you multiply out, you'll be able to get this as your answer. That is how you go about solving this. So very simply, the calculation for parallels of latitude and great circles, they are very similar. Only that for great circle, you're using this R in this formula. You're using the big R. But for latitudes, you're using small r. But noting that this small r is equal to big R cos the angle of the latitude. So that is where we're going to be stopping today. Please, if you like this video, hit the subscribe button by this side of the screen. If you have any questions and concerns, drop it on the comment section. If you want to contact us, check the description part of this video. Thank you and God bless you. Hello, welcome. Today we're going to be looking at calculus. Calculus is a very important mathematics that you have to learn if you're to be writing mathematics in JAMB. When you're in 100 level in the university, you're also supposed to do some things in calculus. Whenever you hear the word calculus, you think about differentiation and integration. What kind of mathematics do we need calculus to solve? Whenever you have expressions or mathematical situations where you have changes, like you have changing velocity, changing acceleration, changing size or container, then you use what we call calculus. And in using calculus, you use the tools in calculus: the limits, differentiation, and integration. So in this our course in calculus, we are going to be covering limits, differentiation, and integration. These three aspects that we are covering under calculus, they are linked together, they are related. From limits, we get to differentiation, and we all know that integration is the opposite of differentiation. So in our time in this course, we'll be looking at these three: limits, differentiation, and integration. So whenever you hear about calculus, we are talking about changes and how to take care of changes mathematically. And this calculus involves limits, differentiation, and integration. So as a matter of getting down the notes, we're going to be looking at calculus. And under calculus, we're going to be looking at limits. We're going to be looking at differentiation, and we're going to be looking at integration. Now, mathematically, integration is the opposite of differentiation. When you integrate, you get back to where you were before the differentiation was made to an expression. So we look at this expression. Given this very expression, if you differentiate this expression,
so officially we are starting tomorrow.
You have this. Now, if you integrate this very expression, you have this, which is actually where you're coming from. So when you differentiate an expression, you have a different expression. But when you integrate, you get back to where you started from. You can differentiate using this formula. So in subsequent classes, we are going to be learning how we arrive at getting from here to here, differentiating, and also getting from here to here, integrating. So you're going to be given a simple expression like this in JAMB or in your further mathematics in WAEC, and you're going to ask what is the derivative of this. So when you ask that question, what is the derivative of this expression, it simply means differentiate this, and when you differentiate this, you get this. And this is the simple explanation of this. Anything that you have up here, take it back here, so that you now have x a n. Then anything that is up here, reduce it by 1. So that is what was done here. When you take this over to this side, it becomes 3 times 2, which is 6. Then anything here, reduce it by 1. You have 3 minus 1, which is 2. So that's how you come about this. So with this expression or with this formula, you can always differentiate. So we differentiated this to get this. Then when you integrate this derivative, you get back this expression. So if you integrate this, you get back this. So in subsequent classes, I'm going to be showing us how to integrate, how to differentiate, and the derivatives of some very, very important expressions like cos theta or cos x. How do we differentiate cos x? Cos x equal to sine x as the derivative. Then how do we differentiate sine x? Sine x equal to minus cos x. So all these major derivatives, x and all of them, all these major derivatives, we're going to be looking at them. We're going to be getting their derivatives and their integrals as well. So if you're told to find, when you work on this, you get this as the integral. So we have derivative, we have integral. So differentiate to get the derivative, then integrate to get the integral. So that's what we're going to be looking at. And I told us before, calculus has to do with whenever we have changes. Very, very important. It's the kind of mathematics that helps you to solve problems that involves changes. Let's say you have a car. And this car is moving at 30 kilometers per hour. You understand? So what distance will it cover in 3 hours? So you're going to have the distance covered will be 30 times 3. So if this car is actually moving on a freeway, but let's take, for instance, this car is actually moving, but some other things are blocking it. You have other bigger cars or smaller cars that are in front. So this car cannot actually move at a constant speed of 30 kilometers per hour. So provided that it cannot move at this constant speed, sometimes it could move at 20 kilometers per hour. Sometimes it could move at maybe 10 kilometers per hour. It's changing, the speed is changing. So how do you now calculate the distance when it has changing speed? Will the distance still be speed times time? So how do you take care of this changing? Because the speed is no longer constant. So you can use derivatives, you can use integrals. So you can actually use calculus to solve this problem. So any mathematical problem that involves changes, you can use calculus to solve. So when we go deeper into how to use these techniques to solve, then you understand how to apply them in problems like this. So we're going to be looking at limits, we're going to be looking at differentiation, we're going to be looking at integration, all in calculus. So one thing to take out of today's course is that whenever you have mathematical problem that involves changes like acceleration, changing velocity, even in physics and in engineering, you're going to be coming across calculus, you're going to be coming across ordinary differential equations and the rest of them. So we're going to be looking at these in details. Please hit the subscribe button so that anytime we release our videos, you'll be the first to get them. Thank you. God bless you. Hello, welcome. Today we're going to be looking at arithmetic progression. We're going to be looking at what? Arithmetic progression. We call it AP. We call it what? AP. We said that a sequence is a succession of terms. You understand? In which the difference between either of the term, the first and the second, or the successive terms is governed by a rule, isn't it? So a special type of this sequence is known as arithmetic what? Progression. Where the difference, you call it common difference. Call it what? Common difference. And the first term is represented with the letter what? A. The difference between successive terms is known as the word common what? Difference. Represented with the letter what? D. Is that clear? And you can find the nth term by saying Tn equal to what? A, which is the first term, plus bracket n minus 1 close bracket D, common difference. Is that good? So we say arithmetic progression AP also can also be called what? Linear sequence. is a sequence in which the increase or decrease between any two consecutive terms is the same throughout. The difference between this and this is the same as the difference between this and this, and the same as the difference between this and this. And that difference is known as what? Common difference, and is 6. Can you see that? 5 plus 6, 11. 11 plus 6, 17. 17 plus 6, 23. 23 plus 6, 29. Common difference. You are going to see that this differs from what we have when we be learning GP. Is that clear? What's the common difference for this sequence? 24 minus 9, 15. 15 minus 9, 6. 6 minus 9, minus 3. Minus 3 minus 9, minus 12. Is that clear? Now, the increase or decrease is called the common difference, and it can be positive or what? Negative. The first term of an AP, A, is represented with the alphabet what? A. Can you see that? The first term of this arithmetic progression is what? 5. The first term of this one is what? 24. The common difference, which is the difference between consecutive terms, is known as common difference. Is that clear? Represented with what? D. What's the common difference for this sequence? 6. What is that for this? Minus 9. Now it will be important to calculate the nth term of an AP, and the formula is what? Tn, which is the nth term, is equal to the first term A plus the term you're looking for n minus 1, all multiplied by what? Common difference. Is that clear? And also very important, another very important formula is the sum of the terms of AP, gotten by Sn equal to n over 2, or in block bracket 2a plus, in bracket n minus 1, multiplied by E. And if you know the last term, you use the formula Sn equal to n over 2, bracket a plus L, close bracket, where L is the what? Last term. Is that clear? And with that, you can solve this problem. The 16th term of an AP is 93. Given that its common difference is 6, find the first and 28 terms. Can we solve this? Class, can we solve this? So I'm going to just take this out, so that we'll solve it. So that we'll do what? Now, having taken this out, what are the given? You can tell me the given. We are given the 16th term, is it not? So we say T what? 16. And it can be represented by using this formula. A plus what? N minus 1 D. And this 16th term is equal to what? 93. Can we see this? This is given, isn't it? So if we impute our values, we have A is what? What's the first time? Not given. So you write A the way it is. Plus N. What is N? 16 minus 1. What is D? Common difference is 6. Is also given, isn't it? Equal to 93. Is that clear? So since there is equal to here, we can remove this because 16 term is already equal to 93. Is that? So we have now A plus what? 16 minus 1, 15 times what? 6 equal to what? 93. You can give me 15 minus times 6, 90. So we have what? A plus 90 equal to what? 93. So that A is equal to 93 minus 90, which is equal to what? So that is the first term, and that's what we are asked to find. First term is that. But we also asked to find 28 terms. So T what? 28 is equal to A. What is A now? 5 plus N is what? 28 minus 1 times common difference 6. A is 3. Thank you. Because that's what we found here, isn't it? So we now have 3 plus 28 minus 1, 27 times what? 6. So who can tell me what is 27 times 6? 162 plus what? 3, which will give us 165. And that is what? T28. Is that clear? That is how to solve it. In subsequent classes, we'll be looking at GP and other things. Thank you. God bless you. Like our videos, subscribe to our channel. Hello, welcome. We are looking at geometry, and we say that geometry is that aspect of mathematics that deals with what? Shapes. That deals with what? Shapes. Is that clear? And the difference between these shapes is due to the angles that the lines are making with each other. Is that clear?
Yes.
So today we are going to be looking at angles. We are going to be looking at what?
Angles.
What is an angle? An angle is that change in direction, is that clear? Or distance between two lines. You understand? Or that is obtained when two lines are diverging from one another. Is that clear? Let's say this one of my hand is an angle. Can you see this? Let's say this is a line surface, a line. This is another line. And they are meeting at a point. This distance from here to this other part is known as the what? Angle. Is that clear? So let's say this is a line. Are you seeing this line? Are you seeing another line? Both of them are meeting at a what? Point. They are meeting at a what? Point. So let's say they are together. Now they are diverging. Is that clear? This distance here is known as what?
Angle.
It's known as angle, and it's measured in what? Degrees. Let's say that it is 33 or 46. It's measured in what? Degrees. That's why we say that an angle or angles are the distance between this line and this line. Distance or change in direction between two lines surfaces. Can you see the two line surfaces? Diverging from the same point. They are diverging from the same what? Point. Measured in what? Degrees. Is that clear? That is what an angle is. And we have different kinds of angle, different types. We have what we call right angle. We have straight angle. We have obtuse angle. We have reflex angle, depending on the size of the angle. Is that clear? So these angle types are actually dependent on the what? Size. Depending on the what?
Size.
Now, the right angle is the angle that has the size of what?
90 degrees.
90 degrees. Or you can call it the quarter of a what? Revolution. Why do you call it the quarter of a revolution? Because if you have a cycle like this, and you divide this cycle into what? 4. One of them is always making an angle of what? 90 degrees. So that is this angle. Can you see that? It's always 90 degrees. Straight angle is the angle that has the size of what? 180. Can you see that? This is straight. 90 plus what? 90. Making it what? 180. That is this. You have acute angle is what? Any angle that is less than a what? Right angle. Can you see that this is less than that right angle? It's less than 90. Obtuse angle is any angle that is greater than what? 90, but actually less than what? 180. It's greater than a right angle, but it's less than a what? Straight angle. Reflex angle is the angle that is greater than 180, but less than what? 360. Can you see that? Can you see this angle? It's bigger than 180, isn't it? But it's less than 360, which is a full revolution. Now we'll talk about complementary angle. Complementary angle. Two angles are said to be complementary if the sum of those two angles is what? 90. Can you see these two angles? This is 90 degrees, right angle, isn't it? Then you have an angle here, A, plus another angle here, B. When you add these two, what will you get?
90.
So we'll call these two angles. Say that both of them are what? Complementary. Both of them are what?
Complementary.
Two angles are said to be complementary if the sum or the addition of both of the angles gives what? 180. Is that clear? Now, supplementary angle. Two angles are said to be supplementary if their sum is equal to what? 180. Can you see that? This is 180, is it not? Straight angle. Now you have angle C plus angle D giving you 180. So angle C and D are said to be what?
180.
They are said to be what?
180.
No. They are said to be what? Supplementary. Angle A and what? Angle C and D are what? Supplementary. Why? Because the addition of both of them gives you what? 180. Is that clear? So these are the kinds or types of angles that we have in geometry. Is that clear? Subsequent classes we are going to be looking at other things in geometry. Please, if you like this our video, click on the subscribe button. Share this our video so that other people can see. Thank you so much for your support. Hello, welcome. Today we're going to be looking at plane mensuration. Today we're going to be looking at what? Plane mensuration. Plane mensuration is simply that aspect of mathematics that deals with finding a way of determining the perimeter and the area of plane shapes. Is that clear? In plane measuration, we'll try to determine the what? Perimeter and what? Area of plane shapes. Or you can say determining the circumference of a circle. Is that clear? Perimeter or area of plane shapes. And we know what plane shapes are, isn't it? The shapes that don't have depths. Example is what? Triangle, trapezium, parallelogram, square, rectangle, isn't it? So today we're going to be starting with that of a triangle. I will say that perimeter is the distance around a plane shape. Is that clear? Are you seeing this plane shape? What is the distance around it? This side plus this side plus this side. Is that not? That is the distance. So if you are told to calculate the perimeter of this triangle, it's simply a plus b plus what?